Welcome to June 27th LeetCode Challenge. Candy. There are n children standing in line. Each child is assigned a rating value given in the integer array of ratings. You are giving candy to these children subjected to the following requirements. 1. Each child must have at least one candy. The children with a higher rating get more candy than their neighbors. Return the minimum number of candies you need to have distributed the you need to have to distribute the candies to the children. So let's go over example here. You have ratings of 102 in this array called ratings, and these are children. Each of them are children. So you want to know how much candy you need to allocate to each child. So you go through the first time. You want to. So my thought process is you go through the array the first time, note the ratings, and the second time you just assign the candies accordingly. So you allocate the first array, you allocate the first, second, and third children with 2, 1, and 2 candies. As in, you give the first one 2 candies, the neighbor is less than it, so you have to give it less candy, so you have to give it 1, because you still have to give a minimum of at least 1 candy. But the neighbors have to be that higher, you need to give them more candy than the actual person themselves. And then you give them 2 candies again, so the minimum you can give to satisfy these 2 points are 5. Likewise this. So you have the first one, you go through, you have the array 1, 2, 2. The minimum candy you need to give is 4. Why is that? You give the first child 1 candy. And the second child has a rating of 2, which is higher than 1, so you need to give it 2 candies because the neighbor's higher. And 2 is equal to 2, so you need to give that at least 1 candy because 2 is not greater than 2. So giving them 4 candies or giving them 1, 2, 1 candies in that order satisfies these 2 points. So we see here that we have n is a big number. Ratings at I is a big number as well. So we got to be careful when traversing through this and searching through that algorithm and trying to figure out which candy to allocate very carefully because it could get really big. So my first instinct or interpretation is to go through the array once, and then we just keep track of all the arrays, of all the ratings, and then we're gonna go through it again and assign the candies, right? And then keep track of the candies we assign. So in that nature itself, it become a dynamic programming question. So let's first start off with a DP array. So we start with a DP array at 1 each, and I'm going to multiply that by the length of the ratings. Okay. So let's cycle through the. So we're gonna loop through the first array once just to keep track of the ratings. So for I in range of 1 to the length of ratings, what we're going to do is we're going to keep track of the ratings. So if the rating is at candy I or child I is greater than the rating at I minus 1, what we're going to do is we're going to update our DP array at index I to know that we have to give a candy to a DP I minus 1 plus 1. So we're gonna loop through our array of ratings once just to keep track of the ratings here. And if the ratings at I is greater than I minus 1, then what we're going to do is we're going to update our DP at index I to note that we have to give it 1, and we have to increment the candy counter index, I guess, of I minus 1 to be plus 1. So we need to know that whether the neighbor is higher or lower than it. Great. So in order to make this, I guess, using one array to keep track of it, the other thing we could do is, so we have one for loop here, and then we're going to do another for loop again to distribute or allocate the candy. So for I in range length of rating. So we're going to reverse the range here. Just going backwards, -2. Nope. Ratings. Yep. -2, -1, -5. So yeah, once we loop through the array, we're at the end. We're just going to loop backwards and distribute the candies. So if ratings at I is greater than ratings. No, we're not going to distribute the candies. We're just going to see if the neighbor before it this time is greater than it before. What am I doing? +1. If that's true, update our dynamic program array at index I to be dp at I +1. +1. Oh, you want to find the max of it actually. Or dp at I. My bad. Then return the sum of the dp array. Okay, let's see if this works. Oh, ratings. Okay, finished. Works. Okay, accepted. So yeah, sorry about that. So first of all, we set up our DP array with 1 because each children has to have at least 1 candy, right? So we have that DP array at the size of length ratings, and then for we're gonna cycle forward in the length of ratings to make sure to assign whether index I and the index I -1, so the one before it, which one is bigger. If not, if the ratings at I is bigger than the one before it, we're gonna add a candy to the one before, because we wanna make sure that the neighbor has more candy than its neighbor because it has a higher rating. Likewise, from here we're gonna loop backwards and see if the ratings at the index is greater than the index before it. Right? If it is, we'll take the max. If the neighbor is higher, then we'll take the max between the index of the one before plus a candy, or do we take the one at index I the way it is, if it's already higher. Then we just return the sum of all the DP array, or the indexes of all the candies we've given out. So let's see. So time complexity is big O of n, because n is the array size of candy of size n traversed twice, I should say. Traversed, yes. Going through a for loop here, another for loop, so there'll be 2n. And then, yeah. And then space complexity is big O of n as well, because we have a DP array here. So the array of candies, DP array is of size n, which is what this array being used. Alright, that's it. Have yourself a nice day.